I'm Nick Mitchinson, and my slide deck's already masked. There we go. So an overview, what we're going to talk about. This is going to go through a brief introduction to Kubernetes, often abbreviated as K8S. So if you see that, I'm talking about Kubernetes. How we can go about running it locally in a VM, then create a basic application in Python. It's really simple. Create our Kubernetes components, apply them, go through the cluster and all that. Finally, tips about how to go to production, as well as some extra tips at the end. These are just small things that I've found work for me. You may or may not like them, you may not want to use them, but I'll put them out there for you. As well, all these slides will be available after the fact, and all the code included here is available on GitHub at that URL there. You can get it if you like. So starting with who I am, again, I'm Nick Mitchinson. I'm a senior software engineer at Cratejoy. I work mostly in SRE, so ensuring that we are fully reliable, as well as on some of our platform-wide architecture. I am NR Mitchie on basically everything on the internet. You can Google me, too. You'll probably find me. So a brief introduction to Kubernetes. Is an open source platform originally developed at Google and donated to the Cloud Native Computing Foundation. It was originally announced mid-2014, and I think hit 1.0 somewhere in 2015. It aims to provide a platform for automating scaling and operations of application containers across a cluster of hosts. Disclaimer, that was stolen from Wikipedia, so that's not my definition. Again, it's used in production at a large number of companies, both big and small. At Cratejoy, we use it for our almost entire production infrastructure. We have one outlier, I can explain that at the end. Locally, for developing and testing our infrastructure components, as well as in our parallel staging environments, which my colleague Josh talked about yesterday. You can find his talk if you want to learn more about that. As well, while Kubernetes does support multiple container runtimes, we're going to be talking solely about Docker here and ignoring kind of the others. So the tools that we are going to be using through this walkthrough is Kubernetes, which we've previously defined, MiniCube, which is a tool set for running a kind of single node cluster locally on your MacBook or your Linux machine. I believe it works in Windows too, I've just never tried it. kubectl is the Kubernetes command line interface. I tend to alias this command as K, so if I accidentally type that, this is what I mean. I'm going to try really hard not to do that, but just heads up. And DNS mask, which provides network infrastructure for small networks. We're typically just using it to resolve a TLD locally. So a brief introduction to the Kubernetes components that we're going to be using. We have a pod, deployment, service, config maps and secrets, and Ingress. A pod is kind of the smallest deployable unit in Kubernetes. It typically contains one or more containers, as well as has shared storage and network inside that pod. There's also an enforcement that containers in the same pod will always be co-located, so they will be running locally together. You can kind of ensure that your other containers in your pod are running. A deployment is an orchestration matching a number of typically stateless pods. I say typically stateless because if you are looking for stateful components, you should probably be looking at stateful sets or other Kubernetes primitives, but we're not going to talk about those here. A service is an abstraction to kind of match against a subset of pods. That subset of pods could be a deployment, and it's just an easy way to get access to them as a whole. Config maps are just arbitrary values that you can inject into your containers as either volume mounts, or you can also inject them as environment variables. Secrets, again, are very similar to config maps. They are in theory meant to be secret, things like your passwords, API keys, and they can be encrypted at rest. Config maps, I do not believe, can. And finally is Ingress, which is a definition of how to route traffic. An Ingress controller in Kubernetes is a special deployment which can read this Ingress configuration and route your traffic accordingly. Any quick questions about those? Anything I need to clear up? No, awesome. So moving on to running this locally. We are going to use MiniCube. MiniCube start will create a single node cluster locally inside your configured VM environment. By default, it uses VirtualBox. That's what I use. That's what I'm going to be using. So I'm just going to make this a little bit wider. Can everyone kind of still see that, or do you want me to adjust it more? We're good? Awesome. So if I just MiniCube start, it's going to start up a local Kubernetes environment. This typically takes 30 seconds to a minute. Other options that you might want to consider here, though, are the memory and CPU options. These get passed through to your underlying virtual machine controller. I personally think they're really important if you plan on deploying anything more than a trivial trial app. Otherwise, you will very quickly run out of CPU and memory resources. I tend to give it about half of my machine. So that's 8 gigs of RAM and 4 CPUs. I'm just going to awkwardly give this a second. I swear it was much faster last time. Pardon me? No, there are other controllers you can use. I believe VMware is also supported, and there are multiple of other options. I'm just not sure what they are off the top of my head. So awesome. That is done. That is built. And our kubectl is configured to use the cluster. The last thing we're going to want to do locally, though, is ensure that our local Docker is using the Docker inside the virtual machine. This is important so that when we build images, they're actually accessible to our Kubernetes cluster. If not, it will try and pull them, and obviously they're not anywhere remote, so it's not going to work. We can do that by evaling the MiniCube output, which just sets up our Docker context. For reference, that's what it outputs. You could, of course, run this separately and just copy and paste it if you are concerned about running output in your shell, which often you should be, but this is a fairly trusted tool. I would just do it. Next step, we're going to create our Flask application. Again, so this was a fairly simple application. I pre-created it. Oh.py. It's the same code. Mostly the same code. There's an extra line in there. All this is going to do is return hello world with its version, which it pulls from the environment, as well as its host. Just to prove that it's going to run, I'm going to run it. It says it's there and it's listening. I can curl it, and it returns. It's an unknown version because it doesn't have an environment set, but it does work. Next step, we need to write our Dockerfile. I'm not going to go in depth into this Dockerfile. I know other talks have covered it. But really briefly, we're building off of Python 2.7, the slim version. It'll work for most things. Copying our requirements and installing them. Copying the rest of our application into the Docker image. Setting this Flask app, which tells the Flask run command what to run. Exposing the port we need. And then actually just running Flask run when the container started. I'm going to go ahead and build that Dockerfile fairly fast, and it's now should be built into my Docker context. I believe, but that seemed too fast because I was in the wrong context. Now it will be building into our MiniCube context. Again, all of these Docker layers are cached, so if you make small changes, it will be faster on subsequent runs. But that was the first run, so it had to download everything. Now that we have our Docker image that we want to run, we're going to move over to our components. Again, I've pre-created most of these, but our deployment simply specifies the API version. This is the Kubernetes API version that we're using. The kind, it's going to be deployment. As well, we want to put it in the PyTexas namespace. Here, you don't actually have to specify a namespace, and if you don't, it will install into whatever namespace you're currently in when you apply this file. I prefer to specify the namespaces just so that I don't accidentally put it in the wrong namespace, especially in the wrong environment. We can set labels, which can be used to select these after the fact. We're just going to use hello world, as well as a name. Your labels don't actually have to match your name. It's just how I tend to write them. Spec, this is the template spec that's applied to pods that the deployment creates. Again, we have to specify some labels so we can select on these. I'm just using app hello world, as well as the containers that should be in each of these pods. Here we're specifying the image as hello world v1. This is what we just created. The image pull policy, if not present. This is actually important when you're doing it locally. If you don't specify this, it will often attempt to pull from a remote that isn't set up, even though the image is present locally. So just include this. The name of the container, as well as container ports that we want to expose. We're listing out 5,000 inside our container, so we're going to expose port 5,000. Our service, again, is an abstraction so that we can access this deployment. Specify the namespace as PyTexas. The label, as the app of hello world and name hello world. And the important part is this spec. In this case, we used a node port that's not actually necessary. I'm not sure why I included that. But a cluster IP is the default, and you can use that. A node port will force you to expose a port on all of the underlying nodes. In this case, we only have one underlying node, but it would expose a port in the 32,000 range that you can hit and access a service as well. So if you had the MiniCube IP, you could hit on that port, as well as the selector. Now, this selector is how we, again, select what pods this service is going to abstract over. In this case, since we specified hello world as our app, or as our app label on our deployment template, we need to specify it as the selector in our service. Now we can go and apply this to Kubernetes. Again, when we set up the MiniCube cluster, it set our kube context to reference this cluster. We can check this, sorry about that, by getting everything and seeing that we're only exposing the MiniCube service, or the Kubernetes service. This is a default in MiniCube, and can pretty tell you that you're running a MiniCube. -F just applies a file. We're going to apply our deployment as well as our service. Except our namespace is not found. This is, again, one of the reasons why I specify a namespace. For instance, if I was trying to apply this to my work production cluster, this would fail, which I personally think is a really good thing. So what we can do first is apply this namespace file. If we want to look at that namespace, it just creates a namespace with a given name. And then we can apply our deployment and our service. I can then pull everything out of the PyTexas namespace. Sorry about that. And we can see that we have a hello world deployment, hello world service, as well as a single hello world pod running. There we go. Now, due to this, because it's fully running and exposed to MiniCube, we can hit our service by IP on MiniCube. MiniCube service is a quick utility to pull a service out of MiniQ and access it. In this case, it returns the MiniQ IP and the port that we exposed. You have to specify the URL, otherwise it'll by default attempt to open in a browser. I just think that's annoying, and I don't like it doing that, so I always specify the IP. Now if we curl this, we can see that our app is successfully running. Again, it doesn't have an environment set, and it's running on this host name that was assigned by Docker. Clearly, this can be a little bit annoying. I personally don't like using IP addresses and port numbers. So I like to use DNS mask, which will allow me to resolve well, really any domains I want, but I use a top-level domain. I use .mk. I know that's not recommended. I don't think the people of Macedonia will mind because I don't use many of their websites. And MK reminds me of MiniCube and lets me not, get confused. So setting this up on a Mac, we, again, need to install DNS mask, as well as set our TLD to resolve locally. We can do this by, again, just adding our name server to the resolver that's on a Mac under etc resolver / whatever your TLD is. You can echo it into there. I've already set it. You can see it's just there. As well as set the IP address that we want to resolve that to in our DNS mask. Config. We can go into user local, sed dnsmask.conf. We can just put this at the end. That's what that command there will do. I happen to know that in the default, this happens to be around line 80. So here we've specified MK as 192.168.99.100. That we know, as you can see down here, is the IP that MiniCube is currently running on. And so that is what we want to resolve to. And yes, those are the same. Finally, you're probably going to have to restart DNS mask for this to actually work. So, I can just use brew to restart it on a Mac. If you're running on a Linux or another machine, you may have to tweak these commands just to get this to work. Google's your friend here. It should be OK. So we shut it down, start it again. And at this point, we need to install our Ingress setup. I got a little bit ahead of myself there. MiniCube runs a DNS or a Ingress controller by default. It's an Nginx-based Ingress controller. This is really nice of them. You can just use that one locally. If you're going to production, you may want to evaluate some of your other options, but locally, we're just going to use this. If we look at that Ingress, again, that I've previously made and I believe is in here, we're again specifying the API version that is an Ingress controller, as well as the namespace in the name. The namespace, again, is important. In this case, it's important because the Ingress has to match the namespace that your actual application, your deployment, and your service are running in. We then specify rules. So I'm going to use helloworld.mk as the domain. So that host will resolve on all paths to the backend specified as service name hello world on the port. The path is something that is treated a little bit differently by different Ingress controllers. In Nginx, this will resolve to all paths. I believe in some others it will only resolve to the root, so just be careful as to which one you're using. At this point, if we apply our Ingress, we'll set it up, and we should be able to curl helloworld.mk, and we get our application resolving. Exact same thing. I don't know what I was expecting here, but it worked. One other thing that I personally like to do is using TLS locally so that my HTTPS requests, properly use SSL. This may not always be necessary for you. At Cratejoy, though, our applications do behave slightly differently if they're served based on HTTP or HTTPS. So having this working is important for us. Again, these are just going to be self-signed certs. They're not going to be valid anywhere else. As well, I'm not going to the steps of actually signing these with a locally trusted CA. So you'll probably have to bypass some browser warnings, but it still works. First step is just create the cert, which we use OpenSSL. As well, we're specifying the entire TLD that we previously specified. You can be more specific here if you want to be. I just like this because it works in my setup. So you can create this, and we're writing it to our temp directory. Then we can use a kubectl shortcut. I must have used this in another context, to create our secret and load it into Kubernetes. Again, Kubernetes secrets are very similar to config maps. They do have 3 different types. You have a Docker registry key type, a TLS type, as well as a generic type. Here we're creating a TLS certificate, so we're going to use the TLS type. We can also look at them after the fact and see that our certs certificate was successfully created and that its type is kubernetes.io/TLS. We can output the certs if we want to save it. For clarity, this is what the config looks like. I've cut off the actual cert and key here, but if you want to save it, this is what you would get. Next step in getting our TLS working, though, is updating our Ingress controller. Now, in my repository, I have this on a separate branch just so they don't crash into each other. But the important component we're updating is the spec. We're adding this TLS object, which specifies the hosts that we want to apply this to, as well as the secret name of the certs that we're going to use. In this case, it's certs. So if we apply this again, it will update, and we should be able to curl on hbs://hello-world.mk. In this case, though, since, again, this isn't a signed certificate from a trusted root CA, we have to specify insecure. However, it is working. Kubernetes Ingress as well has a option that will try and direct all non-secure traffic to a secure connection if a TLS cert is defined. This is configurable, but just a heads up, that might happen to you. So now finally going to production. We have all this running locally, but we're probably going to want to serve it in some other context, at least in a staging environment, hopefully in production. You do have many other options. For production, you can use hosted services such as Google Container Engine. CoreOS Tectonic is an installer and management system that I believe you run yourself, as well as Rancher. We personally use KOps or COPS. I'm not sure about the correct pronunciation there, but it is a tool set that lets you bootstrap and manage a Kubernetes cluster, typically on AWS, but they also support other cloud providers. They also provide easier upgrades as well as rolling node deployments to upgrade Kubernetes in a more reliable way. If you really want to get into it, Kelsey Hightower's Kubernetes the Hard Way repo is a good thing to go through. It's a no script, you do everything yourself walkthrough that will have you setting up a Kubernetes cluster. He uses GCP, but you can use another platform. If you really want to learn how it works internally and how all the components work together, I would go through that. Final tips. I mentioned aliases previously. I alias K to kubectl and MK to MiniCube, just because they're much shorter to type, and I like typing shorter things. I would suggest using a custom default backend for the MiniCube Ingress, especially if you are stealing a TLD. .mk, you most likely will not run into a real site that's using it. But if you do and you type it in and you get nothing, it's good to see a big sign that says, this is local, you're probably doing something wrong if you don't want to be here. Helm, which I didn't talk about, is a tool in the Kubernetes ecosystem. It has pre-built easy to deploy packages for many things. Most services you'll want to run, you can run locally using Helm. I personally use it for Postgres, Redis, Memcached locally when I'm doing dev work. But there are larger, more complicated services that you can run, as well as some companies, Fabricator, for instance, I believe will let you run the entire tool set just through Helm. Finally, you can set a kubectl default namespace for context. I personally use this because in production, we use separate clusters for our production and our staging services. I also use separate namespaces within those clusters. Combined with specifying namespaces on all of our configuration, it makes it so if I accidentally try and apply production config to stage, it just won't work. My default namespace in my prod cluster is prod. Default namespace in my stage cluster is stage. The command to do that is right there. You'll find it in the slides afterwards. MiniCube, some things I couldn't fit on the slides. MiniCube has a collection of default built-in add-ons. The Ingress controller was one of them. They also have a Docker registry credential storage. You can see them with MiniCube's add-on list. DNS is one of them. They're just handy to know about. And if you turn on MiniCube and nothing seems to be responding, chances are the MiniCube IP address changed. There's not really a way to bind it, at least in VirtualBox. So just check that, and you might need to change your DNS mask config. Finally, we're hiring. If you have any questions about Cratejoy, we have a booth downstairs, or you can ask me. And if you have any questions about this talk, I can take them now. And I'll repeat them. Yes?
So you showed how to use TLS in security.
Yes.
How would you change it to use TLS security?
I haven't gone. The question was, I showed how to use TLS in an insecure fashion and how I would go about using it securely. I haven't gone through this process just because I just click the button and I add insecure to my curl request because I know it's local. But I believe the process would involve creating a root CA cert, installing it locally on your machine, then signing the certs that we generated with that root cert, and then using those. That may be wrong, and if someone else knows, feel free to speak up. I'm going to assume it's right. Anything else? Yes?
I was wondering why you explicitly exposed the port in the Dockerfile.
I explicitly exposed the question, sorry, I keep forgetting this, was why did I explicitly expose the port in the Dockerfile? Reason one, I made a mistake and didn't mean to do that, at least in this example. But reason two is, this was loosely based off our production environment when I was putting it together, in which we do expose our ports, mostly so that they work properly with Amazon's load balancers. We expose a service on a port and then just point our load balancer for that to that direct port. You often, if you're using an Ingress controller, don't need to do that. You can just use the cluster IP.
I'm sorry, I meant in the Dockerfile.
Oh, because I think it used to be necessary, and I'm not sure if it still is. Yes?
So, I'm hearing this name Kubernetes talks in the last 2 days. I did. And then you said some history. It's a fairly recent tool. There are several points that are kind of equivalent. I asked this question again. Can you be more specific about use cases where you use other things that are equivalent? You say only use that.
The question was about using Kubernetes versus other equivalent tools, and in which situations we prefer to use one over the other. The main equivalent that I did a comparison to was Docker Swarm for production use cases. The reason I decided we should go down the Kubernetes path was mostly for two reasons. One, Kubernetes offered more visibility into what was actually happening. So if something went wrong in production in Kubernetes, I kind of knew where to look and could say, this is what's wrong, this is how we can fix it. Whereas with Docker Swarm, it appeared, at least to me, as more of a black box that I didn't know how to fix. As well, the community support around Kubernetes I found better. The Kubernetes community has a large Slack team, channel, group, whatever they're called now, that is very active and you can get easy answers from. Locally, you can use Docker Compose, which is another way of tying together some of your services. We actually do use Docker Compose locally in some situations, so these two tools don't have to be exclusionary of each other. Noah?
So you have the name Hello World like 100 times. Is there a real world situation where they differ from each other, and when would that be?
Yes. I'm just going to go back and find the correct slide. In this deployment, for instance, I just used the word Hello World as the app label. You don't necessarily have to use just one label. I did for simplicity. However, you could easily have an app be like PyTexas, its service be web. You can have another deployment where the app is PyTexas and its service is background worker, in which case they would vary. As well, these are duplicated mostly for explicitity, or mostly to be explicit. I believe in Kubernetes versions before 1.8, one of these was the default for the other one. I just can't remember what it is. That I believe has changed in 1.8, so you will have specified in both places. The important part is that this selector on the service, whatever it is, matches the selector in your deployment or your pod or your stateful set or whatever primitive you use.
So you do have to co-evolve those. If it changes, you have to change it in all files?
The follow-up question was, if it changes, do we have to change it in all files? Typically, yes. The name really doesn't matter. The name, if I kubectl get services and specify my PyTexas namespace, the name is what will show up here. So if this changes, you can change it. You don't necessarily have to change your selectors, and vice versa. Just your name should, at least, you should know what it is. Yes?
One example for when you want different names between the deployment and the service is you can have the deployment be Hello World Blue and Hello World Green.
Yep.
And then have the service map to both, but then you can upgrade only the blue, only the green, if you want a green blue.
Yes, that wasn't so much a question as much as a follow-up to my previous answer. He stated that we can have the service and the deployment name differ if we have a single service that is proxying multiple deployments. I didn't specify that they don't have to be one-to-one. We do use this at Cratejoy. Sometimes we have multiple deployments that are backing a single service. Typically, if we want to run something in a canary fashion, or if we want to add extra monitoring in 5% of our traffic, we can deploy a separate deployment that has this extra stuff on it behind the same service. Yes?
You mentioned in passing there was some outlier in the Cratejoy deployment Kubernetes?
That outlier is our one FTP service. Getting FTP running in Kubernetes was not easy. The main reason being that Kubernetes likes to control ports, and you have to specify the port you want. FTP, on the other hand, likes to say, talk to me on my typical FTP port, and then I'll give you a port to send me all the stuff to. that model just doesn't work very well in Kubernetes, so it was much easier for us to just leave that outside of our cluster. If anyone has a good way of doing that, though, please let me know, because I really want to delete that box. I think that's it.